Welcome to Bootcampverse, your universe of tech bootcamps. Good morning and welcome back. You've made it to day 10 of the Code2Corporate bootcamp, and today marks the end of week 2. Over the past week, we've explored vital IT tools and the platforms that form the foundation of modern software development. Yesterday, we dived into back-end APIs, learning how REST APIs, JSON, and tools like Postman help applications communicate with each other. Think of APIs as helpful messengers that carry information between your app's front end and a hidden treasure chest, the database. Today, we're going to peek inside that treasure chest and learn all about databases, especially the kind you'll see most often in real-world tech jobs. Let's start from the basics. What exactly is a database? Imagine you're running a library. You need a neat way to organize all your books, track who borrowed what, and quickly look up information. A database is just that, an organized collection of data. But instead of physical books, it stores everything digitally, making it super easy for software to store, find, and to manage information. Whether you're running a website, a mobile app, or a business system, databases are essential for keeping your data safe, organized, and accessible. Why do we need databases in the first place? First, persistence. Unlike temporary memory, data in a database stays put, even if you turn off your computer or close your app. Next, organization. Data is structured logically so you can quickly find a user's details or view a list of orders. Databases are built for efficiency, handling massive amounts of information and finding what you need in milliseconds. They also help maintain data integrity with rules and constraints that keep your information accurate and consistent. Think of them as digital librarians who make sure nothing gets lost or mixed up. And finally, concurrency. Multiple people or apps can access the database at the same time without stepping on each other's toes. That's a must for any modern application used by hundreds or thousands of people simultaneously. Now, there are several types of databases out there, but today we'll focus on the most common: relational databases. You might have heard names like MySQL, PostgreSQL, or Microsoft SQL Server. These are all relational databases, and they're used everywhere, from e-commerce websites to banking systems. There's also NoSQL databases like MongoDB, but for now, let's keep our attention on relational databases, since they're the foundation for most entry-level tech jobs. So, what exactly is a relational database? It's a database structured around the concept of tables, much like spreadsheets. Each table stores information about a specific entity, for example, customers or orders. Each table is made up of rows and the columns. Think of a table as a grid. Columns go up and down and represent attributes, like customer ID or email, and rows go across, with each row representing one item or record, like a single customer. Let's break down some key concepts. A table, or relation, is a collection of data organized into rows and columns. Each table represents an entity. For example, you might have a customers table and an orders table. Each column, or attribute, represents a specific piece of information about your entity, like customer ID, name, or order date. Every column has a data type, maybe text, number, date, or even a true/false value. Each row, or record, is one instance of the entity. So, in the customers table, each row is a specific customer. The primary key is a special column, or set of columns, that uniquely identifies each row in a table. It's like a student roll number. No two students can have the same one, and it can't be empty. The foreign key is a column in one table that links back to the primary key in another table, creating relationships between tables. Let's see how this looks in practice. Imagine two tables, customers and orders. The customers table might have columns like customer ID, name, and email. The orders table might have order ID, customer ID, order date, and total amount. Here, customer ID is the primary key in customers and also appears in orders as a foreign key, linking each order to the customer who placed it. This is how databases keep things connected and organized, so you can easily figure out who placed which order. Now, how do we actually talk to a database? That's where SQL comes in. SQL stands for Structured Query Language, and it's the universal language for interacting with relational databases. Think of SQL as a set of instructions you give to the database. You can ask for information, add new data, update existing data, or even delete what you don't need. The most basic SQL command you'll use is select. Select lets you retrieve or select data from one or more tables. The basic syntax looks like this. Select column 1, column 2 from table name. For example, to see the names and emails of all customers, you'd write select name, email from customers. If you want to see everything in a table, you can use the asterisk, select from customers. But what if you only want certain rows? That's where the where clause comes in. You can add conditions to filter your results. For example, select from orders where total amount, 100, will give you all orders where the total is more than 100. You can use operators like and/or and like to create powerful filters. For example, select name from customers, where city equals Mumbai and age, 25, retrieves names of customers in Mumbai who are older than 25. Other essential SQL commands include insert into to add new rows, update to modify existing data, and delete from to remove rows. To get it together, these commands give you full control over the data in your database. Databases play a crucial role in the corporate workflow. Back-end developers use database connectors or special libraries to run SQL queries from their code, or they might use ORMs, tools that make it easier to interact with databases using programming languages like Python or JavaScript. Database administrators, or DBAs, are responsible for keeping databases running smoothly, performing backups, and ensuring security. Data analysts and scientists use SQL to extract information for reports and business insights. Even QA testers might use SQL to check that the data matches what the application is supposed to do. No matter your role in tech, understanding databases and SQL will make you more effective and valuable. Let's quickly recap what you've learned today. Relational databases organize data into tables, rows, and columns using primary and foreign keys to create relationships between different pieces of information. SQL is the standard language for interacting with these databases, letting you retrieve and manipulate data efficiently. These skills are essential for almost every tech job, from web development to data analysis. Looking ahead, you've finished week 2, which covered the essential tools and platforms of the IT world. Next week, we're stepping into real-world workflows, starting with an introduction to cloud computing, specifically AWS basics. Fun fact, most modern databases are now hosted in the cloud, So everything you've learned today will connect directly to next week's sessions. Here's your action item for today. Try out an online SQL tutorial or install a simple database like SQLite on your computer. Practice writing select queries. The more you experiment, the faster you'll learn. Congratulations on completing week 2. If you have any questions, drop them below. We're here to help. Don't forget to subscribe to Bootcampverse for more real-world learning that takes you from zero to job ready.